afternoon, MOSI science friends. Welcome to another edition of Live from MOSI, Virtual MOSI. Today we are continuing with our chemistry week, and we are going to talk about physical and chemical changes. I'm Janet. I'm excited to be here today. Shoot us a comment about where you're from, and if you have any questions throughout the live stream, feel free to send those out, and Brian or Armilla will let me know what those questions are. Are you ready to get started? All right, let's go. So physical and chemical changes. Earlier in the week, you talked about elements and what atoms are, and how you can combine atoms to make molecules and compounds. So now we're just going to expand on that further, and we're going to talk about what happens when you start to mix those things up and combine them together. Sometimes you make a physical change when you combine things. And a physical change, you don't really make a new substance. Molecularly, everything is still the same. It might undergo a change of state or a change of matter, or it might even change the shape. But molecularly, it stays the same. Think about if you take an ice cube out of the freezer, and if I were to just set it on the table, what happens to that ice? It starts to melt. It's changing shape. Could I collect that water back up and put it back into the freezer and turn it back into the ice cube? Absolutely. That's why it's a physical change. It's still water, which actually is what this atom is. So it's still the same molecular makeup. It just changed its shape and its state of matter. So when it's a physical change, you can get it back to what it originally was. That leads us to the next one, a chemical change. When you have a chemical change, that means you're creating something brand new. You're taking what you put in together, and molecularly, things are changing. So think about when you light a match. Well, not when you light a match, when your parents light a match. So I have this match, and you can see at the tip, there's a different color. That's actually phosphorus. So when I strike that, and when I blow it out, the phosphorus is actually gone, and we had a chemical change. Okay. When you have that chemical change, it's not usually possible to get it back to what it originally was. I can't get that phosphorus back to create a new match and make it look like it was, because we burned that phosphorus off. Okay? All right. When you have a chemical change, there's some clues that'll help you know it's a chemical change rather than a physical change. Sometimes there'll be a change in temperature, like if you light a candle or when we did the match. It definitely had a change in temperature. It got hotter. Sometimes there's a change in color. Think about if you've ever seen rust on metals. That's a chemical change. You can't get it back to what it originally was. There's also could be a change in smell or taste. You might see some bubbles happening. That's a sign that there's a chemical change. And also, you might form a kind of gas or precipitate. That shows you that there is a chemical change as well. Let's try out some of our things. You might get thirsty while you're staying at home. So right here, I have a beaker with some water, and I have a Crystal Light lemonade packet. So as all scientists do, first we have to make a prediction. When I pour this into the water and mix it up with our stirring rod, do you think that's a physical change or a chemical change? Let's find out. Maybe. All right, let's try this other one. There we go. All right, so let's pour that lemonade in the water. And think back a couple days ago, you might have seen where you mixed sugar and water together to make a solution. That's basically what we're doing with the lemonade. There's still the water, there's still the lemonade mixture, those still stayed molecularly the same, so we made a physical change. Check your predictions and see if that's what you thought. Are we ready to try another one? All right, here we go. So this time, in this beaker, I'm gonna pour some acetone. There's already a little bit in there. I'm gonna pour a little bit more, okay? All right, acetone is the main ingredient that you can find in fingernail polish. So if you don't have pure acetone at home, you could try fingernail polish. The experiment might just take a little bit longer, so you'll want to leave it soaking in the fingernail polish. I also have some styrofoam. So the procedure that we're going to follow is I'm going to put the styrofoam into the beaker with the acetone, and we're going to see what happens. So I have two questions for you. One, what do you think is going to happen to the styrofoam? And two, is it a physical change or a chemical change? Think about that for a second. Feel free to type in your comments or questions. All right, here we go. Styrofoam is going in. Oh my goodness. What's happening to that styrofoam? So, let's think about it. Was that a physical change or a chemical change? Do you think it's actually gone? It's not gone. So styrofoam has a lot of air in it. I bet some of you thought this was a chemical change. Surprise, it's not. It's actually a physical change because the styrofoam is still there, molecularly intact, and the acetone is still there, molecularly intact, but it changed its shape. Want to see that again? There it goes. And there's that styrofoam. All right. Physical change. Are you ready to move on? Let's try another experiment. All right, here we have two flasks. I've already put in the flask some vinegar. I know you saw this yesterday with Mr. Milla, and you tested it to see if it was an acid or a base. Do you remember what it was? I believe it was an acid. All right. And I have 2 balloons and some baking soda. If you have a funnel, this just keeps this a little bit less messy. You can hook the balloon up to a funnel. If you don't have a funnel, that's okay. You can just take a piece of paper and kind of roll it up so that you can get the baking soda into the powder. And I have a portion cup. So I'm just gonna fill that up with baking soda, put it in my funnel so that it goes right into my balloon. I'm gonna add a little bit more. All right. So now we are gonna see what happens when we mix baking soda that we put in the balloon with the vinegar that's already in the flask. Any predictions out there? Okay, let's get it ready. Okay, be sure to look and see what's happening down here and up here. Are you ready? Here we go. Baking soda's going in. Whoop. Make sure you're making some observations. What's happening in the flask and what's happening to the balloon. leave that one there. All right. So think back to one of those clues I told you about, whether it was a physical change or a chemical change when you saw bubbling. Did you see some bubbling happen here? Also, it's hard for you to tell, but when I touched the flask, there was a change in temperature. It got colder. And what happened to the balloon? It got filled up with air. So we saw bubbling, we had a change in temperature, and something went into this balloon. What do you think went into the balloon? We created a gas. All those bubbles, when they popped, it was producing the carbon dioxide, which went up and filled the balloon up so that it was full of air.
Nikki is wondering if they're gonna pop.
Ooh, good question. So, if we left it on like this, it looks like the reaction is over, so I don't think I'm creating any more gas. But what do you think will happen if I just kind of flick it off the top of this? We know there's gas in here. So if I flick it off, will the gas escape? That's getting into Newton's laws. Here we go. Woo! So if we put too much stuff in here and they filled way too much gas and it filled the balloon to where it couldn't hold any more of the gas, then it would pop. But because we used the right amounts, the balloon's not gonna pop. Ready to let this one go? 3, 2, 1, woo! All right, so physical change or chemical change? Definitely a chemical change. All right, since you are home with your parents, I bet you've been helping to cook the meals lately, right? Yeah, I'm sure you have. Most of the time when you cook and put something in the oven, you're making some changes. That's science. You're actually doing science when you cook. So today, I got a little hungry. Doing all this science can work up an appetite. So I brought a bowl with a spoon. Love blueberry muffins. So if I follow the procedure on the bag, because I love science, everything's a procedure. I'm gonna open up the muffin mix. I'm gonna pour it into my bowl. And then I am supposed to add some milk, half a cup of milk, which I've already measured and put in here. So I'm gonna add the milk. And then I just have to mix it up. Mixa, 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 mixa. All right. So do you think I've made a physical change or a chemical change yet? Right now, it's still the muffin mix and the milk. Then, when you've got your mix going, you could do this with cake, you could do it with brownies, anything that you want to cook. You're going to put it in the pan, and then by the magical science at MOSI, once you put it in the oven and apply that heat, out of the oven come blueberry muffins. Ta-da! So my question to you, now that you have this wonderful muffin, can you take the milk back out of the muffin? Can you take just the mix out of the muffin? No, so you've changed their molecular structure and you have created something brand new. And let's taste it just to be sure. And yummy. So you did a chemical change by cooking. So you can tell your parents and teachers that when you're baking, you're actually doing science. Woohoo! Any questions out there about physical or chemical changes?
Brian is wondering if some reactions can be both physical and chemical.
Yes, some reactions can be both physical and chemical. Absolutely. Anybody dye Easter eggs this past week? Was that a physical change or a chemical change? It was a physical change because it's still the egg, but you changed the color. All right. Thanks for tuning in for some more virtual MOSI. Tomorrow, be sure to tune in for when Miss Catherine is going to do some fire chemical changes. Stay safe. Have a great night. Keep discovering.